Good morning, y'all. Today I wanted to continue with our lessons on operations with radicals. The other day we were talking about adding and subtracting radicals. Today I want to go further into the multiplying radicals portion. So when you are multiplying terms or expressions that use radicals, you multiply the coefficients as well as the radicands. Then you simplify the expression. To put that into simpler terms, so this maybe you want to copy down into your notes as well. You're going to multiply the outside numbers you're going to multiply the inside numbers and then you're going to break down the radical to lowest form. Now, the reason that I'm using simpler terms like outside, inside versus coefficients and radicands, sometimes just visually it's easier to see what I'm talking about when I'm saying outside versus inside. So like the coefficients here, when I'm talking about coefficients, that's the outside numbers, right? Those are all the numbers that usually are represented in front of our radicals. And then when I'm talking about the radicands, that's all of our inside stuff. So it could be a number, it could be a number and a variable. So knowing the difference between those two and knowing that vocabulary is important. So your coefficients are on the outside and then your radicands are on the inside. Now, the easiest way to teach this is just to kind of look at examples of how this works. So let's have example 1 here. We're going to have negative 2 square root 12 times 3 square root of 6. Now, doing this problem, you are, didn't mean to shift out here. You are going to multiply your outside numbers, so that's negative 2 and 3 here, so that gives me a negative 6. And then you're going to multiply your inside numbers as well, so that's 12 and 6, which gives me a 48. Now, I don't want to stop here because the square root of 48 can be simplified. Like this is the expression when you multiply them together, but you still want to break down that radical to simplify it a little bit more. So if breaking it down, I can break it down using a factor tree here. So I know this is 16 and 3, and then 16 is 4 and 4. So there's my pair that's going to come out of our radical, and then this 3 is going to still remain. Now, just like we've done in the past, you still have that negative 6 as the coefficient in front that has to multiply with whatever's coming out here. And then the 4 is coming out, so times 4. And then I'll go back. This negative 6 comes out. And then what's left over stays inside the radical, so square root 3. So we get a final answer of negative 24 square root of 3. So that would be your expression simplified. That's just taking two monomials and multiplying them together. We can also do this with a monomial times a binomial. So an example would be if I had 3 square root of 2 times the binomial of 5 square root 3 minus 6 square root 2. Now, what this would look like is this is distribution, so I'm taking this term here and I'm multiplying it to each one of these terms on the inside. Now, the same properties still apply, where I'm going to multiply my coefficients and multiply my radicands together. So here, I'm taking 3 times 15, or 3 times 5, which gives me 15. And then I would take the square root of 2 times the square root of 3, and that gives me a square root of 6 there. And then I also have to multiply this 3 square root of 2 times negative 6 square root of 2. So I'm taking this 3 again and multiplying it with this negative 6. That gives me a negative 12. And then taking square root of 2 times square root of 2, that would give me a 4, square root of 4. And then square root of 4, that actually simplifies, right? That breaks down to 2 and 2. So there's our pair that would multiply out. So this would be 15 square root 6 minus 12 times 2. Oh, I am so sorry. I just caught my mistake. This should be negative 18. Haha. Early morning. So that makes this here negative 18 as well. And then we get a final answer of 15 square root of 6 minus 36. Nothing more can be simplified. I can't add or subtract those together because there are no like terms. There isn't a radical with the 36, so I'm going to leave my answer like that. So that would be a monomial times a binomial, right? One term times an expression with two terms. And then the final example that I'm going to show you here is what happens if we have a binomial times a binomial. So I'm going to have 3 square root of 5 minus 2 times 4 square root of 3 minus square root of 5. For a problem like this, we've done these in the past with variables and expressions like that in our polynomials unit. We're going to use box method, or you can do FOIL. Either or would work. For box method, I'll do that over here. So that's 3 square root of 5 minus 2. And then I've got 4 square root of 3 minus square root of 5. So let's make our box here. So then each box would be the multiple here. So this first square in the top left, it's going to be 3 times 4, which is 12. And then I'm taking the 5 times the 3, which gives me 15. So that expression is 12 square root 15. And then for this negative 2, there is no radical, so I'm really just taking negative 2 times 4, and that gives me negative 8. But this square root of 3 comes along for the ride. And then if I move down to the next row, I have the 3, and then this is a negative 1 here, right? There's a ninja 1 that's hanging out there. So 3 times negative 1 is negative 3. With the square root of, I would take 5 times 5 again, which is 25. And then for the final box, it'd be negative 2 times negative 1 square root of 5. So that gives me positive 2, and the square root of 5 kind of comes along for the ride. So over here, I've got all of my expressions. Let's rewrite them, and it doesn't necessarily matter the order here. So I have 12 square root of 15 minus 8 square root of 3 minus 3 square root of 25, and then plus 2 square root of 5. Now, I don't want to leave it like this because there are radicals that can be simplified. Now, this 15, that would break down into 3 and 5, so none of those having pairs, so that's going to stay as is. That would be 12 square root 15. There's nowhere for that one to go. The 8 square root of 3, that's also going to stay as is. There's no more to simplify, but the square root of 25 is 5. So that means that this is actually negative 3 times 5 as this expression. So negative 3 times 5. And then this also remains as 2 square root of 5. So I have a final answer of 12 square root 15 minus 8 square root 3 minus 15 plus 2 square root of 5. Now, I know I'll get this question. The order doesn't necessarily matter when it comes to like having your plain numbers without radicals at the end, or if you should have like higher radicals front versus in the back. The order doesn't matter as long as you get all of the expressions in that term. So this is a quick video representing how you would multiply radicals. Make sure you copy these down into your notes and then you submit that for your homework on Shobi. We will practice this the next time I see you guys in class. Have a wonderful day. Stay safe. Make sure